Now we are just going to discuss about some of the topics in unit number 1. To start with, we have different types of things. This is called, in general, we call it as conics. It's called conics section, in which we have, first thing is called ellipse. We generally know what is an ellipse. It consists of one major axis and minor axis, and we will draw a curve. It almost looks like an egg. I can say an example as an egg. So this is an ellipse. Then it's a parabola, which you have studied in school time, but we are going to see the construction in this unit. That's what the work is. And third one is hyperbola. Then and next is called cycloid, and then it's called involute. So these things which come under the first part of unit number 1, because unit number 1 consists of 2 parts in total. In first part we have all these types of curves. I can say curve, conics, or you can say different types of curves it is. Okay. And in the second part we have something called freehand sketching. Freehand sketching in the sense, so before that, in the first part, all these things we have to see the construction. So for example, we draw a circle. Okay, we draw a circle. How do we draw a circle in general? We need simply either a radius or I need a diameter. Okay, these values, it is compulsory for drawing a circle. So like this, how do we construct an ellipse or a parabola or a hyperbola or a cycloid or an involute? So this comes under first part in unit number 1. The second half of unit number 1 is freehand sketching. This one, freehand sketching is generally, I can say, see, this duster has got some dimensions. You can say this has got a length. Maybe I can take an example of this length is about 15 centimeter and the width is around some 5 centimeters. Okay, the thickness is some 3 centimeters. So in the normal naked eye we can see this, the width you can see, the length you can see, the width is also as well as the thickness. And but in the diagram, okay, whatever we are doing in the diagram, the diagram will be actually a 2D diagram. That means a 2-dimensional diagram. It's called 2-dimensional picture. Diagram will be a 2-dimensional picture. In the sense, this view, whatever you look from the view 1, this front view, will be just like this. As an example, I'll draw like this. This looks like this. This is the front view. So in the top view, we can see in some other sketch, this is also a rectangle. So I can draw this. This I'll take it as front view. It comes in the front portion. And the top view is something we are looking from the top. So we need a base for that. Meaning for drawing that we are looking in the top view, which can be drawn in the floor. In the sense, here I am drawing it in the bottom. So it's also a rectangle with maybe a width is small according to this duster. Okay. So here we have a dimension, what, say for example this has got a 15 centimeter length. How do I indicate this? This length can be indicated with the dimension here a 15 centimeter, and this width can be maybe some 3 centimeter, etc. This is how. But what do we do it while drawing? We need a pencil, a scale, because a scale is a standard one to measure the length or breadth, whatever it is. So we place the scale on the drawing sheet and then we draw it for 0, say starting point to the end point. That is some right from 0 to 15 centimeter. If the length is 15 centimeter, then etc. all these things. But here the dimensions or the sketch, whatever it is, it should be drawn or marked without using scale. That is what the concept in this second part of first unit, that is freehand sketching. In the sense, I should draw the circle but not with the compass. Without the compass, I have to draw the circle. So it becomes a freehand sketch. I'm just holding a pencil like this, I'm drawing it. Okay, you will not get a perfect circle with this, but it is to test the skill of the student, that is you, to see that how good you have a practice of drawing a circle or drawing a line, drawing a rectangle, drawing a a pentagon, a circle, a triangle, whatever the sides of the polygon may be, or any different types of curves, maybe a semicircle, circle or parabola, all these things, whatever it is, without using the scale. That is what the work we are studying in freehand sketching. So this is how the two parts in the first unit has been divided. Okay, so that is the idea. So we are going to see this one by one, right from ellipse, then go to parabola, then from hyperbola, cycloid and unit number 1. So this carries your 50% of unit number 1, and the second part is, second half is your freehand sketching. Fine, that means. Now we are just going to see the construction of ellipse basically. So in general what we know, the idea is ellipse means we have a major axis and minor axis. That consists of an ellipse. It looks like I said a shape of an egg example. Now here is a question given that draw an ellipse given the following. Given the following means there is some points to be given, because to draw an ellipse you need some parameters which has been given. The distance of the focus from the directrix is 60 millimeter, and eccentricity, second point, is 3.4, 3 by 4 the value. Now before we go to the construction, what I would like to say is the distance of focus from the directrix. See, to construct an ellipse basically you require some parameters. That is, I need, just if I draw an ellipse in general, what do I require here? Before drawing this ellipse or the circle, I require a major diameter. Is this okay? Say suppose I will say AB, this indicates by the line which connects the major diameter, and a minor diameter, say suppose this is my CD. So this I could join like this to make an ellipse. This is what we generally study basically. Now here what I am telling is you need to confine on an area between these two distances. Okay, so I need a starting point. I could take a starting point for this, and from there I should draw an axis line, right? This major diameter, it should be major, sorry, it is major axis. Normally we say it is major axis, and this one is the minor axis. Minor axis. This is how it is. So this we start from a point and then we go through. Now this starting point, in general I can call it as a directrix. This is what it is given as directrix is. Okay, so I need a starting point and I need a distance wherein I should finish the curve also. I cannot take to any extent what I would require, because that a maximum distance which is covered only a major diameter axis it is. This is major axis, it should be a maximum level, maybe it is 30 centimeter or 40 centimeter or whatever millimeter it may be. Okay, so I can fix either in this point or some other a distance point, the other directrix also. This is called directrix. Both are called directrix. I am just fixing an area within which I am going to draw the ellipse, directrix. And something called a word is used is also focus. Focus is a point where from which point I start constructing the ellipse. Is a question. From which point I am going to start constructing the ellipse, because from the starting point of this directrix I need certain distance wherein from there I do all the constructions. That is the base point for constructing all these curves, because these curves have got different I can say the level of angles I can say. So this will be a different angle, and every say a segment has got a different angle, for which I start from a basic single point, from there I start drawing that. So basically I require a distance from this particular point. This point may be anywhere. I can take it and say there is no confined length for this directrix. It's a normal perpendicular line, and this directrix also. But anywhere in this directrix I can choose a point, say for example point A here, and I can draw an axis. That becomes my first set of work. Then I should, from this point I should fix a distance. That distance becomes my focus. That is what is given as 60 millimeter. Distance of the focus from the directrix is 60 millimeter. Okay, we are going to construct it. I am going to tell you how to do it. But generally I am giving the basic idea in what way we are going to make an ellipse or construct an ellipse. So this becomes, this is the idea. So 60 millimeter is given. Then eccentricity is a point, again 3/4 a value given. For an ellipse the eccentricity value is 3/4. In general, what is eccentricity? Eccentricity means from the axis point there is some deviation. That becomes an eccentricity. I can say this body has got an axis here, central point element. From this, how much is my deviation is called eccentricity. So this is also you can present here. It will be 3/4 in the sense, out of this focus length I should give in total value of 4 at 3 measurement. That is, I can say, from, if I say 1/2, you take it in half of the length. If I say 3/1/2/3, out of 3, 2 parts is for one way and remaining is 1 part other. So we will have a 3/4 a value is given for this eccentricity. From this point I should measure at 3 and remaining part goes for the other, in between focus. So starting point to focus I should make a value of 3/4. From there I am pointing out that point is called eccentricity. Okay. Now I am just going to construct proper ellipse with the given values. Okay. Now what I do? Basically I should take the first step, take my directrix. This is my directrix. The directrix it is. I will say this point as CD, C and D. Okay, some point it is, or AB, whatever you can take it. Then I will take another line. It is C1 D1 or whatever. You can, that notation is left to you. Okay. Then I will choose any point in this and draw an axis. Draw an axis. In this first step is to fix the distance of the focus from the directrix, that is 60 millimeter. So measure 60 millimeter from here and fix the focus. This point is F. Say this is F, I fix. This point is my F. Is that okay? And now from this point I will take this point as CD, E. I will take CD is my directrix and then go for E is my fixed point. Some point E is it is. Then I fix my focus F. And then this eccentricity point is also known as, it is indicated by vertex symbol V. Eccentricity is a value 3/4. It is indicated by a symbol V and it's called as vertex. So what I do, I'll just take this value of this vertex also. Say 3/4, maybe at some distance. You are measuring in out of 60, you are taking 3/4. I am just taking this vertex. Now what I do, I will simply take an arbitrary point. Arbitrary means you choose any point within this distance. Simply see this, and you should understand this is 3/4. 3 by length, 3 out of 4. This is 3 and remaining is 1. Is that right? If I have 4 centimeter, I should have measure is 1, other one is 3. That is the value. Now here, total idea is, now I am going to just make some arbitrary point. This is not a distance confined. You choose anywhere, it is okay. But not on this vertex or not on this focus. In between, any point, you can choose it. And this line, you just draw a vertical line. Draw a vertical line, and this vertical line's height, the distance will be this height. Say for example this point, if I take it as 1, and this 1 to F, this distance should be this. If this is the value of suppose 1 centimeter, this should be also 1 centimeter. I hope you can get me. So this is, if 1 centimeter means this is also 1 centimeter. Or you can take just choose a point, you take a compass, keep it here and just make a cut and you just make a line. This line is first step. If this is whatever it is, the line, then I can even draw a arc, not to disturb. I just make it an arc like this. This arc I will make it. Okay. So from this, what you do after getting this point, say suppose this my point is 1, this will be 1 dash or 1 1, whatever it is. From this starting point, any arc, whatever taken, this point E, you draw a line which passes through this point 1 dash. So this distance is here, you are just cutting this point and you take this point as 1 dash. Okay. Now what do you do? Next step is, after this, like you have this curve, this line. Okay. In this line, you should take from every point the remaining part of this. From you take point number 1 here. Point number 2 maybe somewhere you can take here. Take some in approximate distance. I will take 2 centimeter each. I want 2 centimeter from here. Another centimeter maybe here. I will this one and this. And before this, you can even divide this focus distance, that is EF value into equal, say suppose some 6 or 7 equal parts. What I am telling, out of this 60 millimeter, say suppose this 60 millimeter is your distance of EF. This I am dividing into some 7 or 6, I can say 6 equal parts become 10 millimeter is this one value. I'll choose some this 2, 3, 4, 6 etc. and after that I'll just divide this value. I'll choose a arbitrary point 1 and this I measure from the F and I just take an arc and make it a perpendicular line from here, and this I join with the main line. Okay. So from this, after this, like every point you can choose it and just make an arc just by taking this measurement. This may be point 1, there will be 2, 3, 4 etc. It goes on. Number of points, how much you can take, and this every point I can make a line. It goes on like this, because this I am drawing in a board. If you make it in a sheet with the actual distance of 60 millimeter and taking the eccentricity of 3/4, you will get a better sketch. Is it fine? That is better. So you take point by point, and then when you take it, you will get a cut arc. You have to join this to the top. Okay, this inclined line you need to join this every points. Then when you take it, this is the first one, this second, it comes like this, third, it goes like this. It forms. And the opposite side also. It forms like this. Is it okay? So I can say this point, touching point is my point maybe A, and this is A1. This is A2, I can say A1 dash or A2 dash, A3 dash, all this, A3 dash and A4 dash and so on. You can make it. And then opposite side will touch to this, and finally when you make it, you will get a smooth curve, say suppose like this. Okay. So again repeat, this is not a smooth ellipse curve, because drawing in a board you will not get a perfect sketch here, because you need to do a lot of this equal distance. You have to take it and you have to make it an arc perfectly. You will finally get a smooth curve. Say for example like this, I can say like this kind of curve. Okay, I cannot make an exact measurement here. When you make this distance is proper, because when in random when I am drawing, this distance may not be equal to this one. It's not possible. So when you are making a sheet, drawing sheet with the exact length of 60 millimeter and 3/4 the eccentricity value, all this, you will get a proper sketch. This is called ellipse. So this ellipse, and after finishing this ellipse, what you do from this focus point F, you need to take a 45-degree line and join it with this directrix. This step is to draw a tangent. To draw an tangent. After finishing that work, to draw a tangent, this work. From the point F, that is focus point, you take this angle as 45-degree and make it this point. This point may be some value of it. From this point, and if you draw a line for 45-degree, say maybe this maybe line is inclined here by 45-degree. From this line, you should take a 90-degree apart another line. That means if you move the drafter, your mini drafter, fix it here after drawing a 45-degree line which joins at this point. Okay, say suppose FM, this point MF or FM. From this you fix one scale, the drafter. The opposite scale will be exactly a 90-degree apart, is it not? So this 90-degree apart, you draw that line down. So this becomes a 90-degree line. Is it clear? And you need not write it because it's perpendicular. And this touching point, okay, and on this touching point you draw a perpendicular exactly to that. Okay, and from this point you draw a joining point to this. This becomes your tangent, or tangent or normal. This is like this. It should be exactly, this line goes like this fashion. It has to come like this. Again, this is also a 90-degree form. This I would say this is a tangent line, and this is a normal. What is normal? Normal means perpendicular. Normal, nothing but perpendicular line. Is it okay? So this is how you construct an ellipse. So in the question, if it is asked, draw an ellipse with the given following values. Normally it will be giving a distance from the focus point. Focus point is F, and the directrix, this distance is 60 millimeter. Very simple. You should calculate that point, fix your vertex V at a distance 3/4, the distance, and from that point you fix an arbitrary point here 1, and that distance to the focus F you make an arc and bring it to a perpendicular line, and that line you just join it. That's it. Join it, and after that you just divide the remaining line into number of equal parts, and that parts you draw a perpendicular straight lines, and you measure these values and just keep on cutting in this point. And opposite side, whatever you have, this will be opposite to this. If this is 1 centimeter, this is also 1 centimeter. You make a curve. So you try make it in a drawing sheet, you will get a perfect sketch usually. So and after that, making this curve, you should from the focus point you should take a line which is a 45-degree an angle which touches the directrix at the end. I mean at point number M, may say M or whatever distance you can keep it, and from that point you should see that this line to this line a perpendicular line exactly, because when the drafter, if you fix it, the opposite scale will be always, see, drafter is like this, your drafter scale is like this, exactly 90 degree. This always makes a 90 degree angle. So wherever you turn your drafter, opposite scale you can just make it down, and this will be 90 degree. No, this point where it touches, that you join to this point. So this will be touching in a curve, okay? In this curve of arc, maybe if the arc is like this, it will touch like this. This becomes your tangent, and perpendicular to this, you have to draw a normal line. That's what I have drawn it. Okay, this is how we construct an ellipse. This is the first topic in unit number 1. It is first phase, right?